Hello everyone, I hope you're doing well. Today we are going to do 7.7, which is solving radical and rational equations. So our goal is to solve equations that have radicals in them or that have rational exponents. So we have four steps to this. In order to solve it, you want to get the radical alone. So there can be nothing with the radical, either added or multiplied or subtracted or divided or anything like that. The radical has to be by itself. Once you have a radical by itself, you're going to do the inverse operation to get rid of the radical. So for instance, if it's a cube root, you would go ahead and you would cube both sides because those are inverse operations. If you have something being raised to the 2/3 power, the inverse operation of that is going to be the reciprocal. So we're going to raise both sides to the 3/2 power then. Okay, so that's what this next step 2 is saying. You want to raise it to the power equal to the index, which is the third power in our first one. Or the second thing is saying the reciprocal of the exponent. So the 2/3, the opposite operation would be the 3/2 power on both sides. You're going to solve whatever is resulting from that, and then you have to always check your answer. Let's go ahead and see what this looks like in a couple examples. The first one is a square root. The square root is already by itself, so we can go ahead and do the inverse operation and square both sides. When we do that, the square root and the square cancel each other out and undo each other, and you're just left with what's inside, the 3x plus 7. On the other side of the equation, you have 4 squared, which is 16. This results in an equation that we can go ahead then and solve. And when we do that, we get x equals 3. So before we circle this and say job well done, we need to go ahead and check our answer, which means we have to plug it back into our original equation. So we're going to have the square root of 3 times 3, 7. That's supposed to be 4, and if it's not, then we got an answer that is not true, and that would be called extraneous. So 3 times 3 is 9. 9 plus 7 is 16. And the square root of 16 is indeed 4. So x equals 3 is our solution. It works out. Okay, let's try the next one. This cube root is not by itself yet. We have to get it by itself. So we're going to add 2 to both sides. After we do that, we have the radical by itself. We're now going to do the inverse operation. Since my index is 3, I'm going to go ahead and cube both sides. When I do that, I get whatever's remaining underneath here just to be x, and on the other side of my equation, that would be 27. Once again, we have to do it a check one more time to see if our solution actually works or not. So let's plug 27 back into the original equation. The cubed root of 27 is 3, and 3 minus 2 is 1. So x equals 27 is our solution. So let's try the next one. So we want to get the fourth root by itself. We're going to subtract 6 from both sides. We get -1 equals the fourth root of x minus 2. We're going to go ahead and we're going to raise both sides to the 4th power because our index here is to the 4th. -1 to the 4th power is just 1. On the other side, the fourth root and the fourth power are inverse operations. They undo each other. We're left with x minus 2. We're going to go ahead and add 2 to both sides, and we get x equals 3. Before we say that this is our answer, though, we're going to check once again. We're going to get 5 equals the fourth root of 3 minus 2 plus 6. So 5 equals the fourth root of 1 plus 6. So 5 equals 1 plus 6. Now, as we're looking at that, that doesn't make any sense. 5 does not equal 1 plus 6. So what's happening here is that this x equals 3, this solution, is called an extraneous solution. It's a solution that we got that is supposed to work, but when we plug it back in, it actually does not work for one reason or another. So therefore, since our only solution was extraneous, there's going to be no solution to this problem. So let's try the next one here. We're going to go ahead and get the square root by itself, and it is actually already by itself. So now we're going to do the inverse operation, and we're going to square both sides. And we're going to solve the resulting equation. Now, this one is a quadratic. So in order to solve a quadratic, we're going to see a factoring. So we're going to get everything over on one side. We are looking for what now multiplies to get negative 16 and yet adds to get negative or positive 6. The numbers 8 and negative 2 are going to be the ones that work. So we're going to have x plus 8 and x minus 2 as our factors. When we set each of those equal to 0, we end up with two solutions, negative 8 and 2. So now we actually have two solutions that we have to check. So let's go ahead and check x equals negative 8 first. So we have the square root of 16 minus 6 times negative 8. That's supposed to give us a negative 8 out. So we have the square root of 16 plus 48 equals negative 8. The square root of 64 equals negative 8. Well, that doesn't actually work out because the square root of a negative or square root of a number is not a negative number. This is not a solution. So x equals negative 8. This is extraneous. So now what we're going to go ahead and do is we're going to check the other solution, x equals 2. We're going to plug that back into my original equation. And we're going to see if we get a true statement or not. So we have 16 minus 12 under our square root, which simplifies to 4. So we have the square root of 4 equals 2. This is a true statement. So x equals 2. This is our only solution. Even though we thought we might have had two solutions, we end up with only one. Let's go ahead and now move to problems that are radicals, but they don't look like radicals because of the exponent. So the exponent here is 1/3. As a reminder, that is the cubed root. We're going to go ahead and deal with these problems, but we're going to leave them in exponential form. So we're going to get this entire term that is being raised to the 1/3 power alone first. So I'm going to go ahead and add 2. And then after I add 2, I'm going to go ahead and get rid of that 4 out in front. And now my quote-unquote radical is by itself. Then what I'm going to do is I'm going to raise both sides to the inverse operation. So whatever your exponent is, you're going to take that and you're going to flip that fraction, and you're going to take the reciprocal of it. So the 1/3 and the third power undo each other. They're inverse operations. Technically what's happening is you're multiplying these exponents and they're canceling or undoing each other. Which means on the left-hand side, we're just left with 2x plus 11. And on the right-hand side, we actually need to figure out what 3 to the third power is. That's going to give us 27. This resulting equation now is something that I can solve. And I end up with x equals 8. Now, before again I go ahead and say, hey, that's the answer, I'm going to go ahead and check my answer by plugging it back into my original equation. So 2 times 8 plus 11 is inside the 1/3 power. That's a minus 2, sorry. And we're going to see if this is true. So 2 times 8 is 16, plus 11 is 27. We're taking the cubed root of 27 here. That's what that 1/3 power is doing. And so we're doing 12 minus 2, and we do get 10 when you simplify that. So x equals 8 is our solution. So we're going to do the same thing with the next one. We want to get the radical by itself, and that radical is that 1/2 power here. It already is by itself. So now we can go ahead and we can raise both sides to the opposite power. So the 1/2 is going to be the inverse operation of that is going to be the second power. Those cancel each other out. We get 9x minus 11 equals 5 squared, which is 25. And we're going to go ahead and solve that resulting equation. We're going to take our answer and we're going to go ahead and check it to see if it works. So we get 9 times 4 minus 11, which is 36 minus 11 to the 1/2 power equals 5. So 36 minus 11 is 25. The 1/2 power is saying the same thing as the square root. So the square root of 25 is 5. We get a true statement, which means x equals 4 is my answer. So we're going to try 2 more here. So we want to get our radical by itself. So we're going to go ahead and we're going to multiply this by 4 on both sides to get rid of that 1/4. So we have 32b to the 2/3 power equals 1 times 4, which is 4. We're going to go ahead and raise both sides to the inverse operation. So we're going to take that fraction, that 2/3, and we're going to flip it. So we're going to raise both sides to the 3/2 power. And on that one side, we're left with just what was inside the parentheses here, the 32b. On the other side, we need to figure out what 4 to the 3/2 power is. So what we can do is we can write this in radical form. So 3/2 means it's actually the square root of 4 being raised to the 3rd power. And the square root of 4 is 2 being raised to the 3rd power, which means this actually equals 8, because that's what 2 to the 3rd power is. We're going to go ahead and then solve our resulting equation and reduce our fraction to get b equals 1/4. Our final step in this one is to check our solution. So we're going to do 1/4 of 32 times 1/4 to the 2/3, and we're going to see if that equals 1. So as we are plugging that in, we get 1/4 of 8 to the 2/3 equals 1. And I'm going to rewrite 8 to the 2/3 as the cubed root of 8 squared. The cubed root of 8 is 2, and then 2 squared is 4. So 1/4 times 4 equals 1. That checks out, which means b equals 1/4 is my final answer. And so for our last problem here, there's one more with that 2/3 exponent. We want to get the whatever's being raised to that by itself first. So we're going to go ahead and divide both sides by 3. We get x plus 2 to the 2/3 power equals 4. So we're now going to do the inverse operation. We're going to raise both sides to the power that is the reciprocal of that, because it cancels out the 2/3. So we're raising both sides to the 3/2 power. So we need to do 4 to the 3/2 power. Once again, you can think of it as the square root of 4 cubed, and then we would end up with 8 once again. We're going to finish solving our equation and we get x equals 6. And our final check here is 3 times 6 plus 2 in parentheses being raised to the 2/3 power. That's supposed to equal 12. So 8 to the 2/3 power would be what that simplifies to in the parentheses. And again, we can think of this as the cubed root of 8 squared. And so the cubed root of 8 is 2, which simplifies to 3 times 4 equals 12. That checks out, which means x equals is our solution. And so everything worked out with that. So hopefully this helps you solve things that are radicals or anything written to a rational exponent. Have a good day.